everyone. Thank you so much for coming to the afternoon poster session for today's symposium. I'm going to tell you a little bit about my project, but I hope that you'll come see my poster, check it out in a little bit more detail. My project was mainly looking at existing sexual health education standards in the state of Massachusetts for high school students, and then conducting a survey of BU Sargent College undergraduate students and comparing their opinions on what sexual education should look like for high schoolers back to the existing standards. I really wanted to get the opinions of undergraduates who are studying health topics, because as college undergrads, they are close in age to high school students, the kind of students for whom this type of curriculum would be developed, but a little bit removed from that population and able to reflect on kind of the type of health education that they may have received in their own high schools, if any, and to use those insights along with what they've learned thus far in their health-related coursework at BU to kind of have some opinions on health education for high schoolers. And then to compare those opinions back to the Massachusetts Comprehensive Health Curriculum Frameworks, which is the Massachusetts Department of Education optional guideline for health courses in schools all the way from elementary age through high school education. So come check out my poster, and I will see you outside.
Hey everyone, I'm Devin Dial. I'm a computer engineer, and my project is all about how to make biking in the city safer. So from talking to bikers and bike groups, this project kind of evolved into two pieces. The first part is a mobile app, and the focus of the mobile app is providing directions and navigation to bikers. So we use Google Maps to provide the directions, and we combine that with data so that for each step you can see what kind of alerts and what kind of dangers you have for each step of the route. This data comes firstly from the city of Boston itself, so from EMS services and from police. And then secondly, which is kind of the overall focus of our project, it comes from crowdsourced data from the bikers themselves. So bikers can report any crashes, any accidents, anything they see, and this creates a huge database, a lot larger than what police and EMS can assemble. And this data can make bikers, first of all, make better decisions in what paths to take, what routes to take, as well as provide police and lawmakers and people more data to create better decisions. The second piece of the project is a lighting system that can attach to any bike. And what the lighting system does is create a visible footprint on the road for the bike to kind of demark their personal space. And the lights can be controlled by a switch on the handlebars, which allows them to use the light as a turn signal. And this means that bikers can signal their intent in a way that's visible from all angles and is a lot more effective than the hand signals that are impossible to see at night and are counterintuitive. So we're still not done with the project. We have another week to present it for engineering, but come by my poster and see how it is so far. Thanks.
So my name is Will. My Keystone project was translating 2 German language graphic novels into English. This is an idea that came to me when I was studying abroad in Germany last year. I took a very long 7-hour train ride from Dresden to Vienna, and because I needed ample reading material to get me through that time, my friend lent me a German graphic novel, which was actually a piece of graphic reportage by an investigative journalist about the war in Afghanistan from the perspective of the German soldiers. So I started thinking that it would be really interesting for American audiences to have access to that kind of thing. And so I got back to Dresden, started going through the comic book shops and stuff, and ended up deciding not to translate that one. But I did translate these 2. The first one on the right there, or your left, is Reprobus by Markus Weber. It is a biblical story of St. Christopher, which is a really interesting story. It's one of the more pagan-influenced biblical stories, you could say, and he really accesses those elements of it. The second, the German title is Vier Augen, which literally means 4 eyes. I elected to translate that liberally because Vier Augen in German is part of an idiomatic phrase that means sort of like between 2 people, between 4 eyes, so in private is the name that I landed on. So yeah, I'd like to thank my advisor, William Waters, who has been an immense help for me. I absolutely could not have done it without him. And then also Laura Cha, who pretty much helps me through all of my technological stuff. Those of you who know me know that I have like the technological proficiency of like a 90-year-old. So that was an immense help. Come see my poster. I have sort of preliminary prints of both of these in English and the German versions. So thank you.
Hi everybody, my name is Jody Patel, and my project is on human regulatory T cells, but to understand why human regulatory T cells are so significant, you have to understand where we are at in transplant medicine. So when a patient receives an organ transplant, their immune system actually perceives that organ as a foreign material that it wants to kill. So immunosuppression following transplant is extremely important for protection of that graft. Unfortunately, current immunosuppressive therapies are extremely toxic and often lead to cardiovascular disease, nephrotoxicity, and diabetes. And actually 42% of transplant patients die from complications of immunosuppressive drug therapy rather than from non-function of the graft itself. So therefore, the need for less harmful immunosuppressive therapies is so huge. And one way that might be effective in achieving this is through using regulatory T cells. Regulatory T cells are a subset of immune cells that actually suppress the immune system instead of activating it. So the thought is if we can induce their function and exaggerate that function in post-transplant patients, we might be able to find a much safer way of causing immunosuppression. So my work with Dr. Jamil Ozzie at Brigham has focused on the specific mechanisms behind regulatory T cell function, and in tying together my research with past animal trials and clinical trials focusing on the effectiveness of regulatory T cell therapy, I sort of put together a picture of what regulatory T cell therapy is like today and where it might lead in the future. So come check out my
My name's Luke Mertens, and my project was to create a minimalist ankle support technology, aka a brace. The motivation for this was partly personal, but also as I sprained my ankles twice rather severely playing soccer, and really couldn't find something out there that was viable for a proactive preventative measure. But also when I dug into it and looked at the epidemiology of it, I found out that 30% of all sports injuries worldwide are ankle sprains, which I thought was really interesting, and I thought originally it was maybe just isolated to me. But then furthermore, 73% of the people having those sprains tend to have chronic recurrence, and 59% of people there have major impairment from residual symptoms of the injury. And as the injury is most common in ages 14 through 19, this tends to follow you for your life. So this really reinforced the idea to me of going after a proactive preventative solution. The reason I was fairly dissatisfied with what is currently on the market is the products tend to gravitate either towards being prohibitively restrictive in the sense that they're meant for recovery and impair your performance to a point where it's not really viable to use on a regular basis, or they're basically just a placebo, like a compression sleeve that'll just warm your ankle and kind of give you a good sense of it. So the crux of the project was really designing, developing, and then ultimately testing an ankle brace, which I can show and explain to people if you want to come by my poster.
Hi all, thank you for coming. My name is Rachel, and I would like to talk to you today a little bit about the nonprofit sector. So as a starting point, we've kind of all heard about gender inequity in the American workforce as a whole. I'm sure many of you have heard that the current statistic for women CEOs in the Fortune 500 is just 5%. That's 26 of 500. So the nonprofit sector is a little bit less discussed just because of its specificity, but it's an interesting case for the study of gender in the workplace and how that can really affect an entire sector and all of its employees. In terms of background, 73% of the sector is feminine, is female, and just 45% of executive positions are held by women. That actually drops down to 1/5 of executive positions in a nonprofit organization whose budget is over $25 million. So the disparities there are very clear. And as Liza touched on earlier, it's become this gendered profession. A pink ghetto is the term that Liza used. And something that makes this very easily recognizable is that men take a pay cut, all other things comparable, when entering the nonprofit field. So my project has really examined the reasons for this and the stereotypes and beliefs that are held by our culture, and then the systems in the sector that perpetuate those beliefs. And then I've worked on recommendations for the sector to make tangible progress. Thank you.
So my name is Mark Roberto, and I work in the lab of Dr. Ulla Hansen. So liver cancer is the third leading cause of cancer death worldwide. And currently the only FDA-approved treatment is a drug called sorafenib that only improves life expectancy by about 2 to 3 months. So there's a really big lack of treatment. In 2010, the protein that we study in Dr. Hansen's lab, which is called LSF, was identified as being overexpressed in 90% of liver cancers. So there's a lot of it, and so it led us to believe that LSF acts as an oncogene, so it causes the cancer. So my project is two-sided. On one side, I wanted to determine how having too much LSF in a normal liver cell could turn it into a liver cancer cell. And on the other side, we wanted to exploit inhibiting or getting rid of LSF as a means of a treatment. So a few years ago, the Hansen lab, in collaboration with another lab, developed a drug, a small molecule inhibitor against LSF, and so it kills liver cancer cells. So one thing that's really important for the drug discovery process is being able to show how your drug actually works. And so we wanted to know how our drug was killing these cells. And one way to do this is to make cells that are fluorescent so you can image them. So I made liver cancer cells that have essentially glowing DNA, so I can image them as they divide. And then I either treated them with our drug or without the drug and compared what the effects were. And so we did imaging every 4 minutes in time-lapse microscopy, and then we made some really cool videos of the cells dividing, or in the case of the drug treatment, not being able to divide. So if you come check out my poster, I can show you some of the videos. They're really cool, and it's really important for the drug discovery process. Thank you.
My name is Selby, and my project is tuberculosis among refugees in Jordan refugee camps. So I broke my project into 4 parts. The first part is looking at just kind of background on tuberculosis in refugees in general, and then looking specifically at what is being done currently in Jordan refugee camps to screen, treat, and diagnose tuberculosis. And at the end of that section, I found that there were 146 cases of tuberculosis that had been diagnosed, and there are about 700,000 refugees in Jordan. And so looking at the prevalence of TB in Syria before the war, the 146 number is extremely low for the number of actual cases that we should be finding. So the next step of the project was to look at the steps in diagnosing tuberculosis and look at the percentage of cases missed at each step. And then doing that, I found a range of the actual number of tuberculosis cases that should be found in the refugee camps. Then after I found that, I looked at just kind of the financials, extra money and resources that would be needed to diagnose and treat the untreated patients. And then looking after that, I looked at just kind of recommendations going forward and kind of how to find more of the patients that are being missed at each step of diagnosis. So if you find that interesting, come check out my poster. Even if you don't, come say hi.
Hi everyone, I'm Shreya. I'm in biomedical engineering and I'm working with 2 fantastic teammates looking at a problem in drug-resistant tuberculosis. So tuberculosis has been around for a long time, but it's still a huge problem. It kills about 1.5 million people a year. And an increasing part of that problem is drug resistance. We have everything from multi-drug resistant tuberculosis, a significant portion of deaths, to all the way to totally drug-resistant tuberculosis. The problem with drug-resistant TB is that it's a lot harder to diagnose accurately. And 95% of TB cases occur in low and middle income countries where they don't necessarily have as much access to sophisticated technologies. So in places like that, especially in rural field settings where you have very basic rudimentary health outposts, these kinds of places don't have access to infectious disease labs, settings where they can do high throughput sequencing and such methods that would allow you to accurately and quickly determine what kind of TB you have and exactly which drugs it's resistant to. So we are working on a device that can help connect these sorts of patients to that sort of technology without bringing that technology out into the field. So we're designing a device that will take a patient's sputum sample, kill the cells, and extract the DNA and have it in a stable form that can be shipped over to one of these labs. And then you can get the results sent back by text message or by email and get it back within a week, as compared to the conventional method, which can take over 6 weeks to grow the cells out to test them. So it's a lot more accurate. So come over and check out my poster so I can explain in a little bit more detail this complex problem with TB and show you our prototype, which is in progress. So come over.
Well, good afternoon, friends and colleagues. Thank you for being here today. My name is Sam Barnett, and my Keystone project is entitled In Pursuit of a Constructive Learning Environment at the Metropolitan Waterworks Museum. I was advised during this project by the gracious, patient, and understanding Professor Melanie Hall. The Metropolitan Waterworks Museum is located at the former site of the High Service Pumping Station, which was originally constructed in 1888 and is located across from the Chestnut Hill Reservoir. The museum houses 3 large steam pumps and represents a unique fusion of architecture, technology, and social history. This is a comprehensive reflection of an important moment of modernization within Boston. The museum just celebrated its 6th birthday and is still establishing itself within the fabric of Boston museums. This project's goal is to contribute to the Waterworks development by locating useful prototypes for the Waterworks among the fabric of Boston's museums. Specifically, this project seeks to contribute to a constructive learning environment within the Waterworks Museum and to determine both targets and methods for establishing useful school partnerships. Research was conducted through a literature review, as well as a survey and site visits to Boston's Museum of Fine Arts, Isabella Stewart Gardner Museum, Museum of Science, Paul Revere House Museum, as well as Lowell's Boot Cotton Mills Museum. These methods contextualize museum education both theoretically and practically. So please come visit me at my poster, which is a prototype for a constructive educational tool intended to be displayed within the Waterworks Museum, and ask me about the contributions these museums made to the Waterworks.